and visible to all of you, right? Yes, hello everyone. I hope so I'm perfectly audible and visible to all of you, right? And once again, welcome to the first class of this paper discussion series in which we are going to discuss about the NEET previous year papers from 2005 to 2026, right? So this would be a series of around 21 lectures. In each lecture, we are going to pick one question paper and discuss that, right? We are starting with 2005 as you can see, right? And why I had picked 2005, there is a reason, right? Soon you will get to know what is the, like I just tried to identify if there is any pattern or something like that followed, right? So there is a question in 2006 which was asked in 2026, right, as it is. I think some change in one of the values, there was a change, yeah, but yes, questions do repeat, right? So it is not that it's 2005, so they are not gonna ask the similar type of question. Yes, they can do ask, right? So this would be an ultimate and best revision shot for the NEET exam that is gonna happen, because it's been a lot many critics are saying that the exam is gonna be it is not gonna be easy as it was on 3rd of May. So we need to be prepared for the worst, yeah, and hope for the best as usual, right? Please let me know in the chat section how is the Josh, low, high, dead, medium, alive, and let us begin with the session. So hello everyone, my name is Kunal Gupta and I welcome you all to Physics Wallah. Chai pee lo kahin se, swad milega yahi se. And to have the swad, we are starting with this series, right? So please do not get confused. By the way, this smart guy in the photo, it's me only. I just got a haircut because it's so hot here in India, especially in Delhi, right? And I can't take so much burden on my head, so I decided to have a haircut, right? Fine. So without any delay, let us begin with the session, right? Those who are joining for the first time, right? So we are doing 2 series on YouTube for physics. 2 series on YouTube for physics I am talking about, right? First is the most important question series that we had started last week. Second is the previous year paper series, right, in which we are going to discuss papers from 2005 to 2026, right, relevant to your syllabus, right? In most important questions, last week, I hope you got into the, at least into the, you can say or you can say that environment, yes, that you have to attend this class and practice a lot many questions, right? So 40, okay, by the way, I will just, before starting with the question, I will just give you how it used to happen earlier, right? Earlier NEET wasn't there, it was AIPMT, right? Fine, so though I had written it NEET, but NEET wasn't there in 2005, by the way. Fine, it came later on. So most important question series, it would be somewhere in the, I will try some sessions I adjust and have a few more series on MIQ, right? Okay, so let me just give you a brief. Earlier it was All India Pre-Medical Test, right? NEET wasn't there, right? And AIIMS used to conduct its exam separately, right? All India Institute of Medical Sciences, so they used to have their exam separately, right? NEET wasn't there. There was nothing like NEET which existed. Later on, AIPMT, I think from 2007 onwards, right? They had prelims as well as mains, right? As you have in JEE, like you have JEE mains and then you have JEE advanced. You have civil services prelims, then you have the mains, then you have the interview, right? So they also have prelims and mains. Mains questions are very good, right? You're gonna enjoy. Of course, they're gonna make you get used to the harsh questions or any tough questions, right? They are not going to be easy, right? So we are going to do prelims as well as mains question. I believe from 2007 onwards it started, right? 7 or 8. So we will be doing the prelims and mains questions both for physics, right? And then finally came NEET, National Eligibility Cum Entrance Test, which got leaked, right? And you have to give it again. Fine. So this would be the This is the entire structure. I hope it's clear to you. So NEET, it came later on, it wasn't earlier. So let me just clarify. I hope I clarified that thing. So it's not NEET when I'm just writing, assume it to be AIPMT, All India Pre-Medical Test. Okay. Fine. So without any delay, let us begin with the session. There may be some misprinting in the options, so please do not mind. Questions are perfect. Please go ahead and read them. If you are watching this as recorded session, pause the video and try the question yourself. So they are saying a coil in the shape of equilateral triangle. A coil in the shape of equilateral triangle. Okay. Of side L, of side length L. Okay. Is suspended between the poles pieces of a permanent magnet such that plane of the coil, such that the plane of the this B is it's slightly dislocated. If due to the current I in the triangle, the torque tau is acting, then the side length L of the triangle is equal to. So they are saying that you had placed this in some magnetic field. You had placed it in some magnetic field. Okay. And they are saying torque acting on this is given by tau. They are asking what is the length of the triangle. So you need to figure out. So write the formula for torque in terms of length. So it is NIAB sin theta. NIAB sin theta. NIAB sin theta. Right. Theta is 90 degree. Number of turns is 1. What is the area of this triangle? What is the area of this triangular loop? Right? There can be of any shape. It can be circular, it can be rectangular. But this is an equilateral triangle. So equilateral triangle has an area of root 3 by 4 a square. A is the length and length here is L. So this will become root 3 by 4 L square. B is the magnetic field. Sine of 90 degree. Okay. So they are asking you the length here. Send all the things on that side upon root 3 times I into B is equal to L square. Sine 90 degree is 1. Take root both sides. This square and root will get cancelled out. This becomes length. 2 goes out. 2 under root tau under root 3 I B. So this is the value of length I am getting. Is this in the option? Is this in the option? Acha, this is nothing but okay. This is 1 by 2 raised to the power 1 by 2. Fine. Because of some misprinting, it's there. We had used the screenshots. Okay. So this does not have root there. This does not have root there. Okay. This has okay. I think just this has tau in the numerator. This has tau in the this has tau in the numerator. So this should be the correct one. Anyways, in your exam, you will be getting it perfectly written. Okay. Root. Okay. I hope you got this one. This is the correct answer. Moving ahead to the next question. All right. Please let me know in the Josh how many questions. Okay. He had asked a good question. So there were 50 questions in this. They had 50 questions. So we have to do 50 questions today for this paper. Okay, hurry up because it's gonna take a lot of time. Okay, so they are saying that two batteries, one of EMF 18 volt and internal resistance 2 ohm, and other of EMF this much and internal resistance that much are connected are shown. The voltmeter we will record a reading of. Fine. So first just identify whether these batteries are connected in series or in parallel. Clearly, these batteries are connected in parallel. These batteries are connected in parallel. These batteries are connected in parallel. Fine. Right. Okay. Now, what if I replace these two batteries by a single battery? Then my work would be very easy. So what I will do, I will replace this battery by a single battery of EMF E equivalent and internal resistance R equivalent. So EMF E equivalent is given by E1 plus E2 by R1 and R2 here है ना, 1 by R1 plus 1 by R2. ठीक है, EMF is how much? E1 is how much? 18 by 2, this will become 9. Similarly 12 by 1, this will become 12. 1 by R1 plus 1 by R2. ठीक है, this will become how much? 21 upon 2 plus 1 3, 3 by 2. This 2 goes in the numerator. This will become 21 upon 3 into 2. This gets cancelled out on 7. 7 into 2, 14 volt. Fine. Now, instead of these two battery, you can connect a equivalent battery having EMF 14 volt, right? And connect a voltmeter across this. And connect a voltmeter across it. Connect a voltmeter across this. Connect a voltmeter across it. Fine. Fine. Now, this voltmeter would be, they are asking what reading this voltmeter would be showing, right? So, this cell is not connected to any external resistor. This cell is not connected to any external resistor, right? So, whatever would be the EMF would be shown by this voltmeter, right? So, 14 volt. If they would have connected a resistor, then the things would have been a bit different. Then I will show you what will happen. Fine. Okay. See this? A point source emits sound equally in all direction in a non-absorbing medium. The 2 point P and Q are at a distance 2 meter and 3 meter respectively from the source. The ratio of the intensity of the two waves at P and Q will be. Fine. So intensity, it's inversely proportional to square of distance. Intensity is inversely proportional to the square of distance. So they are asking the ratio of the intensity of the waves at P and Q. IP is to IQ is what they are asking. So RP square, RQ square. P is at a distance of 2 meters and this one is at a distance of 3 meters. Square it. 3 square 9. Two square is 4. Option number 1. Option number 1. Fine. Next. See, questions have been very easy and a few of them were quite difficult, right? Especially the mains one, right? You are gonna find it challenging when we do the mains wala part, right? And you guys gonna love this session, right? So be there. If you're watching this as recorded session, pause the video and try out the questions. Okay. A bomb of mass 30 kg at rest explodes into two pieces of masses 18 kg and 12 kg. The velocity of 18 kg is 6 meter per second. The kinetic energy of the other mass. Okay. So they are saying that 30 kg, 18 kg and 12 kg. ठीक है. Fine. So this is a mass of 30 kg. This exploded into 18 kg and 12 kg. 18 kg and 12 kg. Fine. This was at rest. So speed of this, initial speed of this is 0 meter per second. They are saying that the 18 kg moves with a speed of 6 meter per second. Okay. What would be the speed of this? What would be the speed of this? What would be the speed of this? That is what they are asking. Fine. So I can apply conservation of momentum. Okay. By the way, I can assume it to be it is moving in x-axis. So you can write just 6 I cap. This is not gonna put any impact because they are just asking you the magnitude. But anyways, they may give you the direction also. But I am assuming you can take it as j cap, k cap, up to you whatever you want to take. Fine. Okay, so initial momentum is equal to final momentum. Initial momentum is 0, m1 into v1 plus m2 into v2. Fine. M1 into v1 is equal to, or simply you can write m2 into v2 is equal to minus m1 into v1. m1 upon m2 into v1. M1 is how much? 18 kg. M2 is how much? 12 kg. V1 is how much? 6 I cap. Goes on 2, this goes on 9, minus 9 I cap, right? V2. Now they are asking you just the magnitude. They are asking you just the magnitude, 9 meter per second. Sorry. Okay, they are asking you the kinetic energy. You had got the magnitude of the velocity, hai na? That this is gonna move with a speed of 9 meter per second. Okay, what will be the kinetic energy of the second mass? Half mass of the second into v2 square. Half m2 is how much? 12 kg. v2 square 9 into 9. 6 into 81. 486. Option number 2. 486 joules. Fine. Clear? Good question it is. है ना? अच्छा, in option they may give you they may write 9 joules. है ना? So please do not get confused. 9 was the speed that you got for the second mass. Fine. Chaliye, yes, very good. Whosoever is writing in the chat section. By the way, what's your name? This is the spamming name that you had entered. Very good. But what's your actual name? A drum of radius r and mass m rolls down without slipping along an inclined plane of angle theta. Fine. So let us suppose there is an inclined plane of angle theta. Now they are saying there is a drum which is rolling, right, without slipping. They had mentioned it, hai na? So there is a drum which is rolling without slipping. Now here it will have some potential energy, correct? That will be equal to mgh. Fine. Here it will have some potential energy that is equal to mgh. Now that entire potential energy, will be converted to kinetic energy as it comes down. It will be converted to kinetic energy as it comes down. Fine. Now they are asking without slipping along the frictional force. What is the work of frictional force here? What is the work of frictional force here? Now let me just show it to you. Frictional force would be acting downwards, would be acting like this. Okay. Now just a second. Okay, first let me just explain you this. Now this kinetic energy, it will be how much? Half mv square plus half I omega square. Fine. This will be the kinetic energy it is gonna possess. Fine. Now let us suppose this would not have been there. This would not have been there. Okay. Then only you would have got translational energy. For example, this is 10. So this must also be equal to 10. So let us suppose this is not there. Right. Fine. But you are having this rotational kinetic energy also. You are having this rotational kinetic energy also. So if this was 10, right, this is let us suppose 8, this is let us suppose 2. What the frictional force did, it converted some translation wala part into rotational wala part. How was it possible? With the help of frictional force only. So converts translational energy into rotational energy. A good question. Do this one. Those who had joined late, so today we are going doing the 2005 NEET exam. Basically, it wasn't NEET exam, it was All India Pre-Medical Test at that time, AIPMT, and it has 50 questions. Okay, Harshit, you are there? Fine. Hello, how are you? Chaliye, let us see. Imagine a new planet having the same density as that of our mother Earth, right? But it is 3 times bigger than the size of the Earth. radius of the planet is equal to 3 times the radius of the earth, right? If the acceleration due to gravity on the surface of the earth is g and that on the surface of the new planet is g dash, then what is the relation between g and g dash? See how you are gonna do. Acceleration due to gravity, you know it's gm by square of the radius, fine. Instead of mass, see, you know density is equal to mass upon volume, right? Volume is 4 by 3 pi r cube. So mass, from here you will be getting it as density into 4 by 3 pi r cube divided by r square. So this 2r and 2r gets cancelled out, r square and r square gets cancelled out. So acceleration due to gravity, you get it as 4 by 3 pi rho g into r, right? This entire thing is a constant, है ना? Because they are saying that density for both the planets is same, fine. So I can assume this entire thing to be constant, fine. So g is proportional to rho, g is directly proportional to r, fine. So can I write g dash by g is equal to r dash by r. R dash is how much? 3 times re. R dash is nothing but radius of the planet. Radius of the planet. R is the radius of the earth. So g dash is equal to 3 times g. G dash is equal to 3 times g. Option number 1. G dash is equal to 3 times g. Fine. Acha, whosoever has joined the session, make sure you share the link with your friends so that they are also benefited from this session. It takes a lot to prepare and then come up in this live session. Please share the link in your class groups or with your friends who are preparing for the NEET exam. Okay, fine. Again, okay. Oh, a similar question they had asked in NEET 2026, right? Just they had changed the value. Similar question, as it is, the diagram was like this. Now they are saying a network of 4 capacitors equal to C1 is equal to, let me just write it here. C1 is equal to capital C, C2 is equal to 2C, C3 is equal to 3C, C4 is equal to 4C. Okay. Are connected to a battery as shown in the figure. The ratio of the charges on C2 and C4. So they are asking what is the ratio of charges on C2 and C4. You know Q is equal to C into V. C2 into V2 upon C4 into V4. C2 is how much? 2C. C4 is how much? 4C. Fine. V2 and V4. See, now by this time you guys would have been able to get that these 3 capacitors are connected in series, right? You will find equivalent of them and that would be connected in parallel with this C4, fine. But this C4 is clearly connected in parallel with this battery, right? I'm gonna replace them by their equivalent soon, equivalent of these 3. But one thing to is for sure, suppose it is V volt here, so across C4 also it will be V volt. Across C4 also it will be V volt. Let me write it as V volt. Okay, fine. Now you just have to find how much is the potential difference across this. Let me just write it as V2 as of now. C gets cancelled out, this gets cancelled out on 2. V2 upon 2V. V2 upon 2V. Now what will be the value of V2? That we need to find out. Fine. Now see, what will be the equivalent of these 3? These 3 are connected in series with each other. Right. So 1 by C equivalent. Yes, Harshit, please type in the chat box 1 by C plus 1 by 2C plus 1 by 3C. Fine. Take the LCM, you will get 6. 6 plus 3 plus 2. Fine. 6, 7, 8, 9, 10, 11. 11 by 6. C is there. Right. So C equivalent you get it as 6C by 11. C equivalent you will be getting it as 6C by 11. C equivalent you will be getting it as 6C by 11. Okay. Okay. How much charge? 6C by 11. How much charge it would be having? Q is equal to C into V. है ना? तो 6C by 11 potential difference V. ठीक है. So this will have this much charge. 6CV by 11. 6CV by 11. Fine. Now. This is an equivalent of these three only. Fine. So if this is the charge across this, same charge would be across this. Because in series charge remains same. I hope you remember. Suppose these are the two capacitors, so this is having charge Q, so this will also have charge Q if they are connected in series. Fine. Potential difference across them may be different. Fine. Okay. So now you had got how much is the charge across this? That is 6CV by 11, right? Can you get the potential difference across this? Yes. Charge is how much? 6CV by 11. Three by 11V. So substitute here. V and V gets cancelled out. 3 by 22. Is this in the option? Yes. Option number 2. A similar question they had asked in NEET also, but I think they had given the capacitance of these three as same. C. Fine. In fact, for all 4 of them. Okay. Next. Read this. Now they are saying that which of the following circular rods, each made of the same material, okay, whose ends are maintained at the same temperature, will conduct the most heat. Fine. Which of the, so this is a question from thermal properties of matter, right? So they had given different dimensions of different rods, hai na? So there are 4 different rods, right? All of them are maintained at the same potential difference, hai na? So delta T is constant for all of them. Delta T is constant for same for all of them, right? They are made of same material, so this is also same for all of them. Okay. Heat transferred is delta T by R thermal, है ना? Or simply you can write Ka by L into delta T. Ka by L into delta T. Fine. Now, this is a constant, right? So I can say this rate of heat flow, it is depending only on area and length. Fine. Area and length. Area is pi r square. Length is L. So heat is only depending upon the square of the radius divided by the length. Correct? Yeah. A is the cross sectional area. Fine. So just check for which of the pair r square by L. This is the highest. For which of the pair r square by L is the highest. For which of the pair r square by L? है ना? 2 square 4. Okay, let me write it here. R square by L. हाँ. 2 square 4. L square 4 L naught. है ना? So this will become how much? 4 gets cancelled out. R naught square by L naught. है ना? Coming to this. Okay. टू आर नॉट स्क्वायर 4 आर नॉट स्क्वायर बाय एल नॉट. ठीक है. आर नॉट स्क्वायर बाय एल नॉट स्क्वायर. Oh sorry, by L naught. This will be R naught square. This is totally out of option, out of correct league. Options of correct league. Fine. So which of the following will conduct most? Fine. So I think the ratio is highest for the second option. The answer is second option. Okay. So the answer is second. Fine. A very long straight wire carries a current I at the instant when a charge plus q at point P has velocity v as shown in the force on the charge is given by. So they are asking how much force would be acting on the charge, right? Fine. So this is a moving charge moving with some speed v. Okay. Achha, they are not asking how much speed, in which direction it will be, in which direction force will be acting. Fine. So whenever a moving charge is placed in magnetic field, whenever a moving charge is placed in magnetic field, it experiences a force given by qv cross b, qv cross b, qv cross b. Fine. I hope you know that. Suppose you have a cross b and it gives you vector c, है ना? A cross b. Suppose this is vector a, this is vector b. ठीक है. A cross b, ठीक है? A cross b. It is pointing outwards, है ना? So direction of c will be outwards. Fine. So just find out where is v cross b pointing. Where is v cross b pointing? They are gonna give you the direction of force F. They are gonna give you the direction of force F. Simple as that. Fine. Now v to you know it's moving along OX. Now the magnetic field will be because of this current carrying wire. Current is moving in this direction, so magnetic field at this point P will be inside. At this point, see na, curl your fingers, it is coming inside. Fine. The magnetic field is inside. Fine. Magnetic field is inside. Let me just draw like this. And it is moving with some velocity in this direction. So V cross B, V cross B, V, oh, see na, do I have a pen? Yes. So V is in this direction, magnetic field is in this direction. So V cross B. So this is the direction of force that you are getting along over. Moving ahead to next question. Try this out, try this out. A good one. Be careful with the options here. Okay, fine. Okay, done. Now, what it is saying, energy levels A, B and C of a certain atom corresponds to increasing values of energy as EA is greater than EB is greater than EC. Fine. If lambda 1, lambda 2 are the wavelengths of radiation corresponding to transition from C to B, B to A and C to A respectively, which of the following relation is correct? Okay. So here is A, here is B, let us suppose, and here is C. Fine. And here is C. Fine. Now, lambda 1 corresponds to transition from C to B. Fine. Lambda 2 corresponds to transition from B to A. and lambda 3 corresponds to transition from C to A. Fine. Okay, so it is very simple, right? So whatever would be the energy of the photon, okay, you can just think like that. If it would have been vice versa, right, they would have gained. Okay, let us release a photon only. So whatever would be the energy of the photon released here will be equal to the energy of the photon of this plus this. Fine. So can I say that by energy of the photon released here will be equal to energy of the photon of this plus this? Can I say this? Can I say this? The answer is yes. है ना? तो E3 is equal to E1 plus E2. Energy is C by lambda, Hc by lambda 1, Hc by lambda 2. Hc you will take common and it will get cancelled out. 1 by lambda 3 is equal to 1 by lambda 1 plus 1 by lambda 2. Fine. 1 by lambda 3, lambda 1 into lambda 2 plus lambda 1. So lambda 3 you will be getting it as lambda 1 into lambda 2 upon lambda 1 plus lambda 2. This is your answer. Is this in the option? Yes, option number 2. Option number 2. Fine. Next. Try this out, try this out. Okay, whosoever has joined the session, please let me know in the chat section. Fine. Pause the video. Those who are watching the recorded session, pause the video. This is the 2005 paper that we are discussing, All India Pre-Medical Test. NEET wasn't there at that time. Fine. Some very good question. This is a series of 21 lectures. Fine. So stay tuned. Okay, let us see. The work function of metal A, B, C are respectively this much, and this much. According to Einstein's equation, the metal which emit photoelectrons for a radiation of this much wavelength is R. Fine. So there are three different metals, A, B and C. Okay. All of them have a different work function. Okay. All of them have a different work function. But there is a photon which is incident, photon having some wavelength. Okay. The same photon is incident on this and on this. Fine. Now, which of the three metals will emit photoelectron? That means they will show photoelectric effect, you can say. Fine. The metal whose energy is less than the energy of the photon, whose work function, you can say, is less than the energy of the photon incident on them, will show the photoelectric emission. Okay, fine. So find out how much energy this possesses. This is having a wavelength of 4100 Armstrong. This is having a wavelength of 4100 Armstrong, and the energy of this will be, so you can, I know it is Hc by lambda, I know it is Hc by lambda, but you can use another formula, 12400. If wavelength is given to you in Armstrong, you can use this formula directly and you will get energy in electron volt. Fine. I am telling you the condition, you need to substitute in Armstrong only then this formula is valid. You will get the energy in electron volt. Fine. 12400 upon 4100. Roughly 3 electron volt you are getting. Roughly 3 electron volt. Fine. Correct na? 1, 2, 3. Yeah. Fine. So they are asking, correct na? 4100 I had taken. It's 3 electron volt. Fine. which of the metal will permit photoelectrons for the radiation of the wavelength, है ना? Fine. Okay, so all the metals having work function less than this, that is A is having and B is having. So A and B both. Okay. Next. The nuclei of which of the following are isotones, है ना? What are isotones? They have the same number of neutrons. Please type in the chat section. One question for you. I had told what are isotones? Same number of neutrons. And how do you find number of neutrons? Suppose atomic number Z, mass number A, ठीक है. तो number of neutrons is given by A minus A. Fine, simple as that. Fine, clear? Okay. Please type in the chat section what do you mean by isotopes and isobars. Okay, fine. Okay, let us find the number of neutrons for this. 74 minus 34, that will yield you how much? 0, 40. 71, now I am finding for this, minus 31, again it will yield you how much? 40. So number of neutrons, by chance you got the same for the first option only. For others you can check, you will find it different. Now, what they are saying in this question, as per this diagram, a point charge, please try it out, pause the video and try it out, as per the diagram, plus Q charge is placed at the origin, okay, plus Q charge is placed at the origin, work done in taking another point charge, minus capital Q, from the point A to another point B, ठीक है, अच्छा. This is at a distance from here, this, and this is also at a distance from this. Okay, along straight path AB is given by. Okay. Whatever is the work done will be equal to the change in potential energy of the system. You can find initial potential energy taking these two into account. Then you can find final potential energy taking these into account. You will find that these are same only. Fine. Let me just show it to you. U initial, you would be getting it as Q1 into KQ1 into Q2 by A, है ना? Same final, है ना? KQ1 into Q2 by A, okay? Because both the distance hasn't changed, है ना? The distance hasn't changed. So you will find U initial equal to U final. So there is no change in potential energy. The work done will be equal to 0. KQ1 into Q2 by R, KQ1 into Q2 by R. Next. Okay, read this. So they are saying that as a result of changing magnetic flux linked to the closed loop in the figure, an EMF V volt is induced in the loop. So an EMF of V volt is induced. Fine. In the loop, the work done in taking a charge plus Q coulomb along the loop. How much you had taken? Plus Q coulomb you had taken along the loop. Fine. They are asking how much would be the work done. You have one more formula. This is a question from electric potential and capacitance, right? you have a formula delta work done is equal to delta U, but you have another formula that is equal to Q delta V. How much is the charge? Capital Q. Along this path, how much is the potential difference? That is V only. That is V only. QV. Simple. QV. They're asking how much is the value of current. Fine. Clearly I can see 1, 2, 3, 4, 5 and the structure is like this. It's a Wheatstone bridge. It's a Wheatstone bridge for sure. Now, is it a balanced Wheatstone bridge? Let us check. 4 into 3, 12 ohm. R1, R2, R3 and R4. This into this, R1 into R4, 4 into 3, 12. This into this, 2 into 6, again 12. So are these same? Yes. So this is a balanced Wheatstone bridge. This is a balanced Wheatstone bridge. Fine. So that means you can just remove this resistor. Fine. Why you remove this? Because the potential here and here will be same. So this no current would be flowing across this. So this will not contribute in the equivalent structure. This is 4 ohm. This is 2 ohm. This is 6 ohm. This is 3 ohm. Fine. These two are connected in series, so their equivalent resistance is 6 ohm. These two again are connected in series, their equivalent resistance is 9 ohm. Fine. Then they are connected in parallel with each other. Fine. So what will be the equivalent resistance? For two resistors you can just apply this formula. 6 into 9 upon 9 plus 6, 15. 3 it goes on 2, 3 it goes on 5. 18 by 5 ohm is the equivalent resistance. 18 by 5 ohm is the equivalent resistance, but they hadn't asked you this. What they had asked? They had asked the value of the current. So you have the R equivalent. Let us find the value of the current. V by R equivalent. 18 by 5. So 5V by 18. Is this in the option? Yes. Clear? The answer you will get in terms of V only because options are given in terms of V only. Yes, very good. Next. Very simple. A circular motion of a particle with constant speed. Fine. So this motion of the particle, right? So it is moving with a constant speed. After the same time, it will again come back to this position, right? So definitely it is periodic, but this is not SHM. This is not SHM. This is not SHM. This we had discussed multiple times in the class. Read this. Which question we are on? You have to go till 50. Okay. A particle executing SHM of amplitude this much. So they had given amplitude is how much? 5 centimeter. Fine. Has maximum speed this much. Vmax is given how much? 31.4 centimeter per second. fine, the frequency of its oscillation is, okay. Now V, you know that omega under root a square minus x square. This is the formula. Now maximum speed is at x is equal to 0. That is at the mean position. At x is equal to 0. That is at mean position. Fine. Okay. So x is equal to 0. Square root gets cancelled out. V is equal to omega into a. Fine. This is how much? 31.4. Omega is 2 pi into f. A is how much? 5 centimeter. Frequency you will get it as 31.4 upon 5 to 10 you can write upon pi. Pi is nothing but 3.14. Can I write it as 3.14? Yes. By dividing it by 10 upon pi. This and this gets cancelled out, 1 hertz. Fine. Very simple question. And generally from this chapter they do ask questions like this only, where you have to substitute the values directly in the formula and get the answer. Generally most of the time from this chapter. Okay, that is oscillations. Fine. Those who had joined late, let me just tell you, this is the year for which we are discussing the paper for, and make sure you share this link with your friends, with your classmates, those who are gonna give the NEET exam again. Fine. Trust me, you will find question from this series in your exam. Fine. The ratio of dimension of Planck's constant to that of moment of inertia. Ratio of Planck constant to moment of inertia. Now, you may not know what is the dimension. So, see, the best thing is you write the dimensions. Here the whatever is written, it's quite a simple entity. They are having very simple dimensional formulas. Fine. So whatever they are asking, write the dimensional formula of that. Write the dimensional formula of that. Write the dimensional formula of that. Okay. H by I is the moment of inertia. Now, energy is equal to H into nu. So H will be how much? Energy by frequency. Energy is ml square t raised to the power minus 2. Fine. I is the moment of inertia, that is given by, what is the unit? Kg meter square. ml square. Frequency is per second, t minus 1. ml square get cancelled out. This again will cancel out on minus 1, t raised to the power minus 1. That is per second, frequency is per second. Fine, done. Which of the following processes reversible? Fine. See, in radiation and conduction, है ना, heat moves from high temperature to low temperature. Correct? Am I correct? Fine. If you have to move it from low temperature to high temperature, you will have to do some external work. Fine. So this is not possible. This is not possible. Electrical heating of nichrome wire. There the electrical energy is converted to the thermal energy. Again, it's not feasible to convert the entire thermal energy or heat energy into that electrical energy. Fine. Isothermal compression, hai na? Because that happens very slowly. Fine. They had used isothermal word. Read this. The temperature of inversion of a thermocouple is this much and neutral temperature is this much. What is the temperature of cold junction? Hai na? The neutral temperature is given to us as 300 degrees Celsius. Inversion temperature they had given to us as 620 degrees Celsius. Fine. So Tn is equal to Tc is what they are asking, plus Ti by 2. Now, twice of Tn, 300 is equal to Tc plus Ti. $600 minus 620 is equal to Tc. Tc you will be getting it from here, minus 20. Is this in the option? Yes. Next. Try this out, try this out. Pause the video and try it out. Pause the video and try it out. Hanji, yes. A photosensitive metallic surface has work function. How much? So they are saying that work function is h nu naught. Fine. If photons of energy 2 h nu naught, just a second, photons of how much energy? 2 h nu naught. Fine. Fall on this surface, the electrons come out with a maximum velocity of this much. This is 10 raised to the power 6. Okay. Fine. So they are saying that on this surface photon of this much energy are incident, right? And electrons do come out of this. Fine. So you know the general formula. General formula says kinetic energy of the photon is equal to energy incident minus the work function. This is how it works. This is how it works. Fine. Now they are saying that kinetic energy is half mv square. Half mv square. 4 into 10 raised to the power 6. Work function is this much, 2 h nu naught minus h nu naught. You will be getting this as h nu naught. Okay. Now, they are saying that when photon energy is increased to 5 h nu naught. Now, the new photon which is incident it is 5 h nu naught. Fine. Then the maximum velocity of the electron will be, so what will be the corresponding velocity of the electron? Fine, speed of the electron. Okay, so let me just write it in the equation. Half m, v I do not know, v dash square. 5 h nu naught minus h nu naught. So this will give you 4 h nu naught. I can just take the ratio for both of them, here itself. So half m gets cancelled out, h nu naught gets cancelled out. 4 into 10 raised to the power 6 का square, this 4 goes that side is equal to v dash square. Take root both sides. 2 into 4 into 10 raised to the power 6. Eight into 10 raised to the power 6. Clear? Any doubt, any query? Please type in the chat section. How is the Josh? Please. Acha, okay. Whenever I am teaching, I do ask how much percentage is it clear to you. So type in the chat section clear with percentage. For example, it's 80% clear to you. So type in the chat section clear 80%. Okay. It's 1 hour. Almost half of the questions we had done. Read this, read this. Question from the graph of binding energy per nucleon. So remember, this was binding energy per nucleon. And how did the graph look? The graph used to look like this. No. In fission process, fine, what used to happen? Fission of nuclei is possible because the binding energy per nucleon in them increases with mass number. At high mass number decreases. What happens? They're asking. See, as the mass number is increasing, है ना, for elements having higher mass, binding energy per nucleon is decreasing. Binding energy per nucleon, it's decreasing, and that is the reason behind the fission, right? The higher the elements have, the nuclei having higher mass number, right? So they have a lesser binding energy per nucleon, so they do fission so as to increase their binding energy per nucleon. Okay, fine. Why is it feasible? Because binding energy per nucleon is decreasing with mass number. This is a good question, है ना? I can tell you how they can ask you. ठीक है? Applications of forward bias, है ना? They can ask you which of the following is not application of reverse bias. They can ask you a question like this also. Fine. They can ask you a question like this also. Fine. Okay. What happens in forward bias? I hope you remember. Suppose this is the PN junction diode. Suppose this is the PN junction diode. What happens? You connect them, the P side with the positive higher potential, and the N side with the lower potential. Fine. Now, in reverse bias, it happens vice versa. You connect N side with the higher potential, right? So what happens in that case? Depletion layer widens up, right? And potential difference across the depletion layer, it also increases, and electric field also increases across that, and because it has widened up, and more ions are there. Okay, fine. So all these three are the applications of reverse bias, you can say, but what happens here? You had connected it with the negative terminal, right? So what it will do? It will make the flow of electrons more, fine, on the N side, across the junction, and to increase in the number of donors on the N side, increase in number of donors on the N side. They can ask you question like that also. This is raised to the power minus alpha t, this is raised to the power beta t. Fine. Try this out. Again, a good one. Try this out, good one. Motion in a straight line. Yes, In the immediately next room, Yashika ma'am is taking the class for bio on the PW India channel, right? And I can hear her voice. Alright, so what it is saying, the displacement x of a particle varies with time as this. Okay. X is equal to a into e raised to the power minus alpha t plus b into e raised to the power beta t. Fine. Where a, b, alpha, beta are positive constant, the velocity of the particle will be. And to find the velocity, you need to first differentiate this with this. Let me just write it here. You need to differentiate the above with respect to time. So a is a constant as it is. E raised to the power x differentiation is e raised to the power x only. Fine. Whatever there is instead of x, you apply the chain rule, you differentiate that again, so you minus alpha. E raised to the power beta t, e raised to the power beta t as it is, whatever is there in front of that, right, beta. Fine. So v you get it as minus a alpha e raised to the power minus alpha t plus b into beta fine. Achha, okay, this is the equation for velocity you had got. Now let us find out the acceleration also, because with the help of acceleration you will get to know, you will get clarity how velocity behaves, right? Whether acceleration is constant or not, or it's increasing or it's decreasing, it's positive, negative. So you will get the clarity about that. Now, how do you find acceleration? You differentiate the above with respect to time. Again, whatever is there, e raised to the power x, e raised to the power x differentiation is e raised to the power x only, and now whatever is there instead of x, just differentiate this. A alpha square e raised to the power alpha t beta square e raised to the power beta t. Fine. Now, acha, a minus b लगाना. Fine. A alpha square, let me just write the acceleration here. A alpha square upon e raised to the power alpha t plus b beta square e raised to the power beta t. Fine. Now this always you will get a positive value, right? Same here also. Fine. So acceleration, it's always you are getting a positive value, right? So the speed, what will happen? It keeps on increasing with time. It keeps on increasing with time. See, drops to 0 when alpha is equal to beta. You try substituting alpha is equal to beta. Will it drop to 0? No. No. You will not get it 0. Independent of alpha and beta? No. You are getting it in the formula, right? It's decreasing with time? No. Fine. So I hope I had clarified the reasons. Again, question of work done, the one we had done in the beginning only, similar to that. Okay. Now, what they are saying is that, now I will try to save some time. Yeah. I will try to save your time in this particular question. Now, it is a similar question. Two charges Q1 and Q2 are placed 30 centimeter apart as shown in the figure. Hai na? So here is Q1 and here is Q2. Okay, very good. A third charge Q3 is moved along an arc. Okay, so here is charge Q3. Fine. Of radius 40 centimeter. Okay. So you had moved this Q3 from here to here. So if I draw the initial diagram, how does it look? This Q2 is here. and this Q4 is here. Sorry, Q3 is here. This is the initial condition. What is the final condition? Okay. The change in the potential energy of the system, है ना, delta U is what they are asking, है ना, so you need to calculate the final and the initial potential energies both, है ना, U final minus U initial is what you need to calculate. Okay. Okay. Finally, you had brought Q3 here. Okay. So Q1 is here. Q2 is here and Q3 is here. Fine. Okay. Fine. Now just find the change in potential energy of those pairs whose potential energy has actually changed. For those pairs only whose they had given you the potential energy in this terms and they are asking you to find the K. First you find how much is the change in potential energy, then we will compare them and find the value of K. You can just write X here to avoid confusion. So they are asking you to find the value of X basically. Fine. Okay. Now I know this pair and this pair you are planning to take, and again this pair and this pair you are planning to take. The answer is no. Take only those pair, you know that is KQ1 into Q2 by R. You know that this is the potential energy. Okay. Now take only those pairs into account whose potential energies are actually changing. If it is not changing, why to take unnecessarily? Fine. Why to take unnecessarily? So I am giving you a hint. See, this is at 40 centimeter. Okay. Afterwards also, this will be 40 centimeter only. The distance between Q1 and Q3. Q1 and Q3. Afterwards, it will be 40 centimeter only. Yeah, the distance is 30 centimeter. Afterwards also distance is 30 centimeter. So they will not contribute in the change. Only these two will be contributing in the change because the distance is 50 centimeter here and the distance here is 10 centimeter. Fine. Now find out the answer quickly. I am giving you 10 seconds, please. Those who have joined the session late, we are doing the 2005 paper. Yes, got it? Hanji, yes. Anyone got the answer? Please type in the chat section. Okay. So here the potential energy between 2 and 3 charge will be how much? K Q2 into Q3 by 50. Here between 2 and 3 charge will be how much? K Q2 into Q3 by 50. Fine. What will be the change in potential energy? U final minus, oh sorry, this will be 10. K Q2 into Q3, this minus this, है ना? This Q2 into Q3 can come common. 1 by 10 minus 1 by 50. Fine. K Q2 into Q3. 50 is the LCM. 50 minus 10, 40. 4 by 5. है ना? K value can be written as 1 by 4 pi epsilon naught. Q2 into Q3. This can be compared with this. And this can be compared with this. They are saying that Q3 upon, oh, एक second. हाँ, 1 into Q3 upon 4 pi epsilon naught into x, है ना? They had taken it as, अच्छा, whole into है ना, तो x यहाँ पे आएगा, ठीक है. So you just need to compare and find out the value of x, है ना? This is the change in potential energy you had got. They are saying this is what we are saying is the change in potential energy, and find out figure out the value of x from here. You just compare them. Q3 1 by 4 pi epsilon naught, Q3 1 by 4 pi epsilon naught, है ना? Did we do any mistake here? 40. अच्छा, okay. This is 40 है यहाँ पे. This is 40 है ना? 40 minus 10, हाँ, 40 कर लीजिए इसको, है ना? 40, 4 minus 1, 3, correct? Three by 40. Just a second. अच्छा, okay. सेंटीमीटर में, है ना? सेंटीमीटर में we are supposed to convert it into meter, है ना? ठीक है. There is in denominator there is centimeter, है ना? तो you multiply it by 100, है ना? 1 meter is 100 centimeter, है ना? You multiply by 100, you will get it in meter, है ना? So we need to multiply by 100 as well, है ना? So let me just multiply it here only. Two, 5. I think I should write it again so that there is no confusion. Just a second. Hanji. Okay. So change will be between Q2 and Q3 only. This is not changing between Q1 and Q3, and between Q1 and Q2, this is not changing at all, है ना? K Q2 into Q3. अच्छा, okay, it is 50 only, na? Why had taken? Oh, I'm sorry. It is 50 only. This distance we were supposed to take, it's 50 only, है ना? So delta, if you want, you can just multiply by 100 here, है ना? Because this is in centimeter. So 2K Q2 into Q3, है ना? This will become 10K Q2 into Q3. Delta U is equal to U final minus U initial, है ना? 10 minus 2, you can just write 8K Q2 into Q3. This is delta U. Now you can just compare it with Q3. 1 by 4 pi epsilon naught is nothing but K only into X. Now it is done. KQ3 gets cancelled out. X you are getting it as 8 times Q2. X you are getting it as 8 times Q2. Option number 1. Clear? A good question. Now you have to convert the centimeter to meter. That was a fault. In a fission process, the ratio of mass of fission product to the mass of parent nuclei, है ना? Here are the reactants and here are the products. ठीक है. So there is some energy lost, है ना? Energy mass equivalence you would have studied, right? Some mass lost in the form of energy, है ना? ना, some mass lost. Okay, mass of product is less than the mass of the reactant. So when you do the ratio of mass of product by mass of reactants, you get it less than 1. Option number 1. You get it equal to less than 1. Fine. Next question. Achha, slightly we need to increase the speed because we are running a bit behind. Okay. Achha, wherever required, I will explain you the concept. We are having just 1 hour. Try this out. Try this out. Give me a. Actually, it's lunch time here in India. Sorry, dinner time here in India. So I was getting something for myself, right? Hanji, try this out. Try this out then. I'm coming to that. Alright, I hope so I'm perfectly audible to all of you. Let us resume. Now, most of the people, they did a mistake when this came in exam. Okay, this is first vector and this is second vector which is not arranged in sequence. So, you were supposed to arrange this in sequence, right? For j cap minus 4 I cap. So, minus 4 I cap was supposed to be written, thank you, minus 4 I cap was supposed to be written initially, right? Fine. So they are asking what is the value of alpha if these two are perpendicular. If these two are perpendicular, then their dot product must be 0. Take the dot product of both of them, multiply with the I cap ones with the I cap ones. 2 into minus 4, 3 into 4, 8 into alpha. This is equal to 0. Minus 8 plus 12 plus 8 alpha. This is equal to 0. This is 4 plus 8 alpha is equal to 0. So alpha from here you get it as minus 4 by 8 or minus 1 by 2. Option number 3. Next. Zener diode is used for stabilization, है ना? This is used as a voltage regulator, voltage stabilizer basically. Okay. चलिए. Now, an ideal gas heat engine operates in Carnot cycle between 227 and 127 degrees Celsius. It absorbs this much heat, 10 raised to the power 4 it is. Okay. At high temperature, amount of heat converted to work. Okay, let me just teach you this concept. So this is the source which is at a temperature T1. Q1 heat is extracted by the engine. Fine. And Q2 heat is wasted in the sink. It's sent to the sink basically at temperature T2. And W amount of work is done. Okay. Now, amount of heat converted to work, that is what they are asking. Fine. Amount of heat converted to work. They are asking value of the W. Now, what all things they had given? Between 227 degrees Celsius. So, T1 is 227 degrees Celsius. At 273 to convert it into Kelvin. 300. This becomes 500 Kelvin. This is how much? 127 degrees Celsius. Add 273 to this. 73, 200. 400 Kelvin this becomes. This becomes 400 Kelvin. Okay. It absorbs this much heat. So Q1 is how much? 6 into 10 raised to the power 4 calories. ठीक है. Amount of heat converted to work. Very simple, very simple. Can I apply the formula? T1 by T2 is equal to Q2 by Q1. First let me get Q2. Q1 into T1 by T2. Q1 is how much? 6 into 10 raised to the power 4. T1 is how much? 500. T2 is how much? 400. 2 zeros, 2 zeros gets cancelled out. Gets cancelled out on 2, 3. 15 by 2. Or you can say 7.5 into 10 raised to the power 4 calories. ठीक है. They're asking amount of heat converted to work, है ना? तो work done is equal to Q1 minus Q2. Q1 minus Q2. 400, 400, 500. This is absolutely done. 2, 300 and 400. Yes, correct. It absorbs 6 into 10 raised to the power 4 calories of heat at higher temperature. ठीक है, this is correct. ठीक है, let us see. They are asking work done, है ना? Q2 minus Q1. Q2 is how much here? No, it's not approximate. Exact answer we are getting for this. Okay. 5, 3, 15. 15 by 2. This is what we are getting, na? 7.5. Yes, correct. We had done. Okay. Okay, we will just come back to this. Okay. Read this. Read this. It's not an approximate answer. Exact answer we are supposed to get here. Okay. Now they are saying that a force F acting on an object varies with distance x as shown here. The force is in Newton and x is in meter. The work done in moving the object from this to this. I hope you remember this formula. Okay, but they had given a graph. So you can just find area under this graph. You can find area under this graph. Area under the force and displacement graph. Area under the force and displacement graph. Area under the force and displacement graph. Fine. This you can find. Work done will be equal to half into, this is a trapezium, half into sum of parallel sides, 3 plus 6 into distance between them, that is 3. 6 plus 3 is 9 into 3. 18 by 2, that makes it as, 27 by 2, that makes it as 13.5 joule. Is this in the option? Yes, option number 2. Is this in the option? Yes, option number 2. Fine. Next question. A stone is tied to the string of 1 meter long, is whirled in a horizontal circle with a constant speed. If the stone makes 22 revolutions in 44 seconds, what is the magnitude and direction of acceleration of the stone? Fine. So there is a stone that you had tied to the string and you are moving it in horizontal plane. You are moving it in horizontal plane. You are moving that stone in an horizontal plane. You are moving that stone in a horizontal plane. Fine. They are asking what is the acceleration. Okay. See, acceleration is v square by r, and r is the length of this. Okay. V square by r. Instead of v, I can write omega r, omega square r square by r, or simply omega square into r. Okay. Now, see, it is making 22 revolutions in 44 seconds. 22 revolutions in 44 seconds. So, can I find out the frequency? Yes. 1 by 2 per second. That is the frequency. Okay. So, acceleration I would be getting it as, this is how much? 2 pi into frequency whole square into the length of the string. R is the radius, that is the length of the string. 4 pi square into frequency square into length L. Frequency is how much? Length is how much? 1 meter. 2 and 2, 4 gets cancelled out. So, acceleration you are getting it as pi square. Achha, these are squares. ये square है ना? These are squares. Okay. Fine. And direction is towards the center. Direction is towards the center. Next. Now, this is a comparison between dia, para and ferromagnetic substance. So, you know that. Achha, read the question very carefully. What they are saying that if the magnetic dipole moment of an atom they are talking about, of an atom of diamagnetic, paramagnetic and ferromagnetic. An atom they are talking about. So an atom, it's here the dipole moment of an atom. Okay, they are representing dipole moment as mu d, mu p and mu f. Here it is 0. Here it is equal to 0 for a diamagnetic substance, right? Which of the options is? So this is incorrect, this is incorrect, because they are saying mu d is not equal to 0. Fine. For it, yes, they do have. Even for ferro they do have. Okay. This is not equal to 0. For an atom they are talking about, not as the matter as a whole. Fine. Okay. So which of the following satisfies this? Mu p they had given again 0. Mu p to some value, slight value is there. Next. Okay, these sessions would be of roughly 2.5 hours, right? So we will try to wind up with those 50 questions around in 2.5 hours, but the 2007 to 2011 paper they are gonna take a bit time because they will be having the mains questions also. Fine. In an LCR circuit connected, okay. So it's an LCR circuit. Very good. Now, read the data one by one. The current leads the voltage by 45 degree. Okay, let us suppose here is my current. Here is my VR and even the resistance is in this direction. Here is my VL, or you can say XL is also in this direction. Here is my VC, or you can say XC is also in this direction. Fine. Now they are saying that the current leads the voltage by 45 degree. Okay, so current is leading, so definitely VC would have been more than VL. VC would have been more than VL, so you would have got resultant of these two in this direction. Fine. And resultant of these two in this direction. This would have been VC minus VL. Okay. Now, this is the resultant. So, the current is leading the voltage by 45 degree. It's overlapping. I had drawn at some distance just to showcase you clearly. Okay. The value of C is what they are asking you. Okay. Now, tan 45 degree in this will be given by tan 45 degree in this. Okay, the resultant Z you can say here under root R square plus XL minus XC minus XL whole square. Okay. C की value is what they are asking you. C की value is what they are asking you. Okay. Fine. Is there any shortcut I can use? No. I will have to solve it. Okay. So this phi, tan phi will be equal to how much? Opposite side upon adjacent side, this XC minus XL, or you can write this as XC minus XL also. This is not needed at all. This opposite side upon adjacent side, XC minus XL upon R. Okay, done. Tan 45 degrees 1. XC is how much? 1 by let me write it here. X is 1 by omega into C. XL is omega into L. Into C minus 2 pi F into L. Divided by R. Acha, R I am sending that side, tan 45 degrees 1 only, hai na? So this will become 1. C key value is what they are asking you. Send it this side, R plus 2 pi F into L. Send capacitance this side, 1 by 2 pi into F upon R plus 2 pi into FL. Is this in the option? Yes. 1 upon 2 pi F into R plus 2 pi FL. ठीक है, fine. एक second. F, here is a minus. Okay, fine, done. Clear? Any doubt, any query? Fine. These are the questions that can come in your exam. Fine, or a similar type of question can come in your exam. Fine. Oh, how many of you are tired in the? Please let me know in the chat section. है ना? And if you are watching this video as a recorded session, just pause the video and then move it to the next. Okay. You know, recently, like 2-3 days back, a few of my army friends, they came, right, and like I met them 2 years after. It was so fun meeting them, and they were just telling their entire life. It's not easy, you know. That is what I realized. They are posted at a location from past 3 years, and and it's very monotonous. You need to just forget your family. Very limited leaves they get, and it's tough life, man. I'm like, every day I get a chance to go back home and see my family, and it's very tough for them. They have to be there on time. Yes, try this out. Very simple. Angular acceleration is what they are asking you. ठीक है, angular resolution, not angular acceleration. ठीक है. Now this is तो very simple, direct formula based, है ना? 1.22 into lambda by d. Fine. Let us see. Lambda is 5000 Armstrong, so I will have to multiply it by 10 raised to the power minus 10 to convert it into meter. D is how much? 10 centimeter. Again, I will have to divide it by 100 to convert it into meter. This gets cancelled out. Into 10 raised to the power minus 6. Fine. How much roughly you get? Okay, they are asking what is the order. Okay, order so you had already got. When you multiply this, you roughly get 5, 5, 5, 5, 5. 6 point something into 10 raised to the power minus 6 है ना. Order तो you had already got 10 raised to the power minus 6. ठीक है. Next. Oh. ठीक है. We have, I think, one more question, similar question in the 2006 ones. Okay, those who had joined the session just now, we are discussing the paper of 2005, All India Pre-Medical Test, and at that time NEET wasn't there. Okay, two vibrating tuning forks produce a progressive wave of this much Y1 and Y2, number of beats produced per minute. ठीक है. For the first one, omega 1 is how much? 500 pi. ठीक है. कंपेयरिंग इट विद a sin ओमेगा t, है ना, तो you compare, you get 500 pi. Omega 1 is how much? 2 pi into f1. Pi se pi gets cancelled out. f1 is how much? 250. Omega 2 is how much? 506 pi. ठीक है, again comparing it with this is 2 pi into f2, 506 pi. 506 into pi. Pi and pi gets cancelled out. f2 you would be getting it as 253. Fine. Now they're asking number of beats produced per second. So what will be the beat frequency? First let us find it out using delta f, and you can just subtract f2 and f1 simply, है ना, तो you get it as 3. ठीक है, beats per second, है ना, but they are asking you per minute, so you will have to multiply it by 60, so you get it as 180. Okay, so the questions that you would be easily be able to do, I will just tell you the approach. क्या कह रहा है? What is it is saying in this question? When a wire of uniform cross sectional length L and resistance capital R is bent in a complete circle, resistance between two diagram. Oh, see, there was a wire, है ना, of some length L and resistance R, है ना, some resistance R and length L. Now imagine you had broken it into two parts. ठीक है, connect these two parts. अच्छा, by the way, if the resistance of this original wire was R, this will become R by 2, this will also become R by 2. Now this R by 2 and R by 2 are connected like this. ठीक है, or they are bent in the form of a circle, it's one and the same thing. Now they are asking what is the resistance between two diagrammatically opposite points. ठीक है, तो across these two points they are asking, you can just imagine these two are connected in parallel with each other. So R equivalent will be how much? R1 into R2 upon R1 plus R2. Correct na? Yes. Or simply R by N also you can do if it's both the resistances are same, है ना, तो R by 2N. N is the number of parts, number of resistors connected in parallel, are connected in parallel, so R by 4. Option number 1. Clear? Any doubt, any query, guys? You guys can unmute and ask, please. Carbon, silicon and germanium. Carbon, silicon and germanium. Fine. All three belonging to different periods but the same group. Okay. Have 4 valence electrons each. The valence and conduction band are separated by energy bands represented by this. Then which of the following is this? है ना? Clearly, they are having more conductivity as compared to carbon. Why? Because in case of carbon, the valence band and conduction band, they are having a lot distance. ठीक है, तो energy gap of carbon is more than that of silicon. See na, the valence shell of carbon, it is more closer to the nucleus. It is more closer to the nucleus as compared to the other two. Now you have to write, I am going to tell you a trick about the electromagnetic waves. I hope you remember Mr. CY said to Mr. X that you are a very intelligent media radio partner. Mr. CY said to Mr. X that you are a very intelligent media radio partner. Cosmic rays, gamma rays, X-rays, UV rays, visible rays, infrared, microwave and radio waves. Fine. Now, the one on this side, they are having high energy. If they are having high energy, so they will be having high frequency also. Yes or no? If they are having high energy, so they will be having a high frequency also. Fine. And that's why they are used in cancer treatment also. Fine. Okay. And see, they can't have a high energy. The radio waves, microwaves, they are used for communication. Fine. How can they have high energy? They will penetrate through our skin. Anna. So you can just think like that also. Okay. Okay. What about wavelength? They are having a lesser wavelength. The frequency is high, so wavelength would be less. Here the wavelength will be more. Okay. So we have to compare the X-rays, visible light and microwaves. Wavelength of microwaves is more as compared to visible rays as compared to X-rays. XVM. MVX. Option number 3. Option number 3. Clear? So they can compare any of them and ask you a question. I hope it's clear. Next. Wow, very good question it is. Fine. A lot many people were not able to do this when it came in exam at that time. Alright, now what it is saying in the question, let us understand. Two boys are standing at ends A and B of a ground. So these are the two ends A and B of the ground. Okay. These are the two ends A and B of the ground. AB is equal to small a. Fine. Now, the boy at B starts running in a direction perpendicular to AB. So this boy starts running in this direction. Okay. With velocity v1. The boy at A starts running simultaneously with velocity v. Now this is moving in this direction. Fine. With velocity v and catches the other boy in time t. Fine. So if this is running in this direction, he will have to run in that direction to catch him at some point. And definitely he will catch him on this line only. Let that point be P where he catches him. Fine. Now, he said that they are running with a speed V. They are running with a speed V in this direction. Okay. And now they are asking you, by what is the value of, okay, what is the value of time here? Clear with the question? Clear with the question? Very simple it is. Now, both of them start running simultaneously. That means at the same time. So, if he has travelled for t time, he will also travel for t time. Okay. Both of them should have travelled for the same time. Correct, guys? Okay. How much will be this length? This BP? Distance is equal to speed into time t. How much will be this length? AP. Distance is equal to speed into time t. ठीक है. Can I apply Pythagoras theorem? According to Pythagoras theorem, AP square is equal to AB square plus BP square. AP square is how much? VT whole square. AB square is how much? A square. BP square is how much? V1 T whole square. Send it this side. V square T square minus V1 square T square is equal to A square. Fine. T square you can take common. V square minus V1 square is equal to A square. This is the answer. Is this in the option? Is this in the option? Options there is some misprinting. V2 square, V1 square, and A square is also here. But this is the correct one. V square minus V1 square. Thoda sa misprinting is there when we had attached the screenshot from the PDF where we had taken. Okay. Fine, clear? Oh, man. It's already 10:30 as I said, 2.5 hours, 11 p.m. Those who had joined late, we are on to the first lecture of our series 2005 to 2026 papers we are going to discuss. Okay. This is again a very simple. A 5 ampere fuse wire can withstand a maximum power of 1 watt in circuit. The resistance of the fuse wire they are asking. So power is equal to I square into R. Resistance will be how much? P upon I square. Power is how much? 1 watt. I square means 5 ka square. 1 by 25. Let us multiply and divide by 100. So this will become how much? 4. 0.04 ohm. Yes, to the so big fan base. I hope it's clear to you guys. And so many kids had joined. I'm overwhelmed to see that. Okay. Please. Acha, make sure you share the link with your classmates or schoolmates. Two bodies have their moment of inertia. Two bodies have their moment of inertia in the ratio I is to 2R. Okay. Fine. About their axis of rotation, their kinetic energy of rotations are also equal. Okay. Fine. Their angular momentum will be in the ratio. Okay. Their angular momentum L1 and L2 will be in what ratio? Fine. Angular momentum is I into omega. Angular momentum is I into omega. Okay. Kinetic energy is half I omega square. So can I divide both of them? Kinetic energy by L. I से I gets cancelled out. Omega से omega gets cancelled out. Fine. ठीक है. Okay. Omega by 2 is what we are getting. So L can be written from here as 2k by omega. L can be written from here as 2k by omega. Okay. Angular speed to they hadn't. Fine, I think I will have to write omega in terms of, this can be written as 2k upon I whole under root. Fine. Okay, omega can be written in terms of I also, है ना, under root 2k upon I. Fine. Okay, finally L you had got it as 1 minus 1 by 2, 1 by 2 only, under root 2k. Okay. Yes. Correct. Fine. Now can I find the ratio? Now it will be easy for me to find the ratios. So they are asking you L1 is to L2, है ना, under root 2k1, see na, root of 2k1 into I1 divided by root of 2k2 into I2. Now L1 is to L2, this 2 and 2 to gets cancelled out, k1 and k2 are same, I1 is to I2. And I1 is to I2 is given to you as 1 is to 2. ठीक है, तो 1 is to root 2 is what you are getting. Clear? Any doubt, any query, you guys can unmute and ask. No. In fact, omega value you could have substituted directly here only. है ना? It would have been better if you would have substituted omega value. You would have found the omega value and substituted here, or vice versa could have also been done. है ना? So in fact, that would have been very easy. है ना? Omega is equal to L by I. है ना? Substitute here. K is equal to half I L square by I square. So K is equal to L square by 2I. है ना? You could have used from here also under root 2K. That would have been easy. Fine. Clear? Any doubt, any query? Please let me know in the comment section. Right? I will just reply to that. Next. Okay. Now, what this question is saying, there is an electron having the moment, there is an electron which moves in a circular orbit with uniform speed v. Fine. So, there is an electron which is moving in circular orbit with uniform speed v. Okay. It is moving with uniform speed. It produces a magnetic field B at the center of the circle. At the center of the circle, okay, just you can think like that. There is a charge which is moving, or you can say that there is a current which is moving. Okay. And what is the magnetic field at the center due to a current? Mu naught I upon 2R. Okay. The radius of the circle is proportional to, है ना? Okay. So radius will be mu naught upon 2B. Now instead of current, I can write it as current is nothing but charge flowing per unit time. Current is nothing but charge flowing per unit time. Now suppose V is the speed. Speed is equal to distance upon time. Time is equal to distance upon speed. 2 pi r upon speed v. Okay. Electron. Q is n into E by T. N is the number of electrons, only one electron is there. Time period you get it as 2 pi r upon V. Okay. So you can just substitute that here. I would be getting it as E into V upon 2 pi r. So B and V they are asking. So radius is directly proportional to V or B के terms में they are asking V by B. Option number 2. Clear? Any doubt, any query? You guys can unmute. I was about to say unmute and ask. ठीक है. Next. Choose the false statement. Read carefully. They are asking you the false statement. Substances with energy gap of order 10 electron volt are insulators. This is correct. Fine. Conductivity of semiconductor increases with increase in temperature. When you increase temperature, their resistivity decreases. That means their conductivity increases. So this is also correct. In conductor, the valence and the conduction band may overlap. This is also correct. Fine. The resistivity of a semiconductor increases with increase in temperature. This is a false statement. Okay, it decreases. False. So this will be your correct answer. Fine. Very good question related to vectors they had asked. Now, in this they are saying that A and B are vectors and the angle between them is theta. This is A, this is B, let us suppose. Okay. And angle between them is theta. Now, B cross A. When you do B, or let us suppose let this be B, let this be B and this be A. B cross A. When you do B cross A, a lot of you would have marked as option number 3, but this is wrong. This is wrong. Why? See, B cross A, whenever you do cross product, you get a vector quantity. So B cross A, when you do, it will be outwards. It would be outwards the plane. Let me just draw like this. See vector, it would be outwards the plane. Dot A, 1 minute. Let me just draw like this. B cross A. Suppose you got vector C like this. Now, suppose this is vector C you got. C dot A. CA cos theta. Or CA cos, what would be the angle now? See, this is vector C. Vector A is still in plane. Angle is not theta. Angle is now 90 degree between them. And cos 90 degree is nothing but 0. Cos 90 degree is nothing but 0. Okay. Try this out. Yes. Now, they are saying the total energy of an electron in the first excited state is equal to minus 3.4 electron volt. Okay. It's kinetic energy in this state. Kinetic energy cannot be negative, so these two options will be eliminated. You remember 2 times kinetic energy is equal to minus 2 times the total energy. Fine. I hope you remember this is equal to the potential energy. So just pick this relation. 2 and 2 gets cancelled out. Kinetic energy is equal to minus total energy. Minus minus becomes plus. So kinetic energy you get it as plus 3.4 electron volt. Option number 4. Option number 4. Similar question. For a satellite moving in an orbit around the Earth, the ratio of the kinetic energy to potential energy is. Similar question. The same relation I would be using. 2 times kinetic energy is equal to minus 2 times total energy is equal to the potential energy. Just pick this relation. 2 times kinetic energy is equal to the potential energy. The ratio of kinetic to potential. Ratio of kinetic energy to potential energy is given by 1/2. Fine. Clear? Any doubt, any query, you guys can unmute and ask. Oh, sorry. You guys can comment in the chat. Hanji, yes, how is the preparation going on? Please let me know in the chat section. Okay. This is the only drawback. Very less kids are there in the live session. Then they watch this as the recorded session. Okay. Last question for the evening. Motion in a straight line. Again, a very good question you are having in front of you. All eyes on the board. A ball is thrown vertically upward. So there is a ball which is thrown vertically upward. With some speed, we do not know how much speed. Okay. It has a speed of 10 meter per second when it reaches half the height. It was supposed to reach here. I do not know with how much speed you had thrown, but here definitely the speed is 10 meter per second. Fine. When it has reached half of its maximum height, how high does the ball rise? Hai na? So this is h by 2. Okay. Now from here it has to travel another h by 2. From here it has to travel another h by 2. From here it has to travel another h by 2. Okay. Now at the topmost point, definitely the speed must be 0. At the topmost point, definitely the speed must be 0. Fine. Now you just study the motion from this point. Let us suppose this point is A and this point is B. Okay. From A to B. From A to B. From A to B. Right. Can I apply the equation V square minus U square is equal to 2AS? Final speed is 0. Initial speed is how much? 10. Twice of acceleration is minus 10 meter per second square. Displacement, let us suppose it is h by 2. 2 and 2 gets cancelled out. Minus 100 is equal to minus 10 h. Minus minus gets cancelled out. H is equal to 10 meter. Option number 2. Fine. So before we end the class, okay, now the attendance has suddenly risen. I don't know why and how. Yeah, when we had just completed the last question for the evening, right? Those who had joined late, please do join on time from tomorrow onwards. We are discussing the question papers from 2005 to 2026. Today we had started with 2005 and winded up with that. There were 50 questions. Why? Because NEET wasn't there at that time. It was All India Pre-Medical Test, AIPMT. AIMS used to have its own test. So that was separate. Fine. Later on that also got merged here. Fine. And then we had the National Eligibility cum Entrance Test. So those who had joined late, we had discussed the 2005 question paper. Make sure you just go back and watch the recorded session of this in fast forward mode and share the link. Please type in the chat section how was your experience. Thank you very much for choosing Physics Wallah, and we would be meeting in the next class. Bye bye. See you. And the next class is tomorrow 8:30.